Hello everyone, welcome to CSE Core Concepts. So now I am going to discuss about two-dimensional arrays. Before starting with two-dimensional arrays, in case you have missed my earlier video on one-dimensional array, please go through that link and then it will be easier for you to understand about two-dimensional arrays. So let us assume that I have been given a shelf. Now I am properly organizing everything in as a data structure. So I have been given a shelf where I am going to keep all the books. So this is what my one dimensional array. Now I have lot of books and I am keeping a cupboard where I have two columns, okay, and multiple rows. So this is what makes it two-dimensional. So if I want to search for a book, I have to first know the row location and the column location. That is, both the locations are important in order to find for a book. So here, if I want to set the data elements in a similar way, then a tabular structure would be beneficial. So this is how I can store, you can see the elements. So it is a two-dimensional array because I have to mention row as well as column. So rows here are starting from index 0 to 3. That means I have 4 rows, and columns from 0 to 4. So I have 5 columns. So the data elements are denoted as A of 0, 0. So when I am saying A of 0, 0 means what? 0th row and the 0th column element. Second value is 0, 1 means 0th row and first column, and so on. So my last element will be A of 3, 4, that is third row and fourth column. Just understand that these are the positions which I am referring to. Actually, the value will be stored, and to extract the value, you have to use the position array. So that is why I am focusing on the positions. So when it is beneficial, say I want to store marks of 10 students and I have taken 4 tests over the full semester. So I want to store test 1, test 2, test 3, test 4. So I can declare an array of size 10 cross 4. That means 10 rows because I want to store the details of 10 students, and 4 columns because I want to store the marks of 4 tests. Okay, so the total number of elements here is what? 10 into 4, that is 40 elements or 40 data values I am storing. Now, how to represent it in a memory location? Now, as you all have seen or understood by now, that array is stored as a contiguous memory location. So whether it is a two-dimensional array, so it cannot be stored in a tabular format in the memory location. It also has to be stored in a one-dimensional way. Okay, so there are two major ways of storing the array. One is a row major order, where you first store the value of first row, second row, and so on. And second is the column major order. So you can see in the row major order, first 3 consecutive elements belong to row 1. So the element is A of 0, 0 means 0th row, 0th column. Next is 0th row, first column. Third one is 0th row, second column. Similarly, then starts your second row or first row. So first row, 0th column, first row, first column, and so on. Okay, so all the rows will be stored in this way. Or you can go by a column major order. That is, first you store all the elements of column 0, then you store all the elements of column 1. So A00 means 0th row, 0th column. A10 means first row and the 0th column. So we are focusing only on the first column, right? 0th column. So this way, either you can go by row order or you can go by column order. Now, how to find out the addresses? So again, I would recommend you, in case you have missed my one-dimensional array video, please go back there and see the formula how to compute the physical location address in case of one-dimensional array. So this two-dimensional array is just an extension to it. So it will be easier for you to understand. So if I want to find out the location of any particular element, so how would I? The formula says the location of jth row, kth element. This is a row major order. So jth row and the kth column is equal to the base address of that array plus W. W, you remember, it is the number of words per memory location. into n. Capital N represents the number of columns. J minus 1, K minus 1. Why am I using J minus 1, K minus 1? Because I am assuming 1 is the lower bound of the array. Okay. Similarly, if I am going for a column major order, then it is jth column and kth row, then base is equals to base of A plus W, that is the number of words, into n. So in case of column major order, n is the number of rows in the array, k minus 1, j minus 1. Okay, so let us see one example. So I have a two-dimensional array M, which is of type integer, and the size is 3 cross 4. Okay, so I have 3 rows and 4 columns in the array. So the base address of M is given as 100. So M is starting from location 100, and I am saying W is equals to 2 because as I have declared M as integer, so integer requires 2 bytes in the memory. So short int. Okay, I am referring to as short int. So short int requires 2 bytes in the memory. So W is equals to 2. So if I want to find the location of the element 2, 3, as per the row major formula, then location of 2, 3 is equals to 100. What is 100? 100 is the base address of the array plus 2. 2 is what? The number of words. In 4 into what is 4? The number of columns. Remember, if you are finding in row major order, n is going to be the number of columns in the array. So the number of columns is 4 into 2 minus 1 because I want to find the location of 2, 3. So I am doing 2 minus 1 plus 3 minus 1. So my value is coming as 112. Okay, so 112 is the memory location of the element located at position 2, 3. Similarly, if I want the same thing to be find out using the column major formula, okay, then in that case, it is 100 plus 2, that is same, 3. Now why 3? Because there are 3 rows. So you remember it is a column major order. So we are going to use the number of rows. 3 minus 1 plus 2 minus 1. So the value comes out to be 114. Similarly, you can extend the number of dimensions in the array as per the requirements. Till now, I have discussed about one shelf. If I keep the books, that is one dimensional array. If my shelf has 2 columns and multiple rows, it is 2-dimensional array. Now you assume that I have 5 bookshelves. Each bookshelf has 2 columns and 5 rows. Understood? So, if I want to pick up a book from the library, then first I will have to find out the bookshelf. Okay, so I have 5 bookshelves. So let's say my book is located at bookshelf number 2. In bookshelf number 2, where is the book located? At say first column and third row. Okay, so how many dimensions I require to locate the book? I require 3 dimensions. First to locate the shelf, second to locate the row, and third to locate the column. Understood? Now let's say I have 10 rooms. In each 10 room, I have 5 shelves of book. Okay, so if I want to find out a particular book, first I have to know which room that book is. So first I will go for that room. Then I will go for the bookshelf because in each room there are 5 bookshelves. So I will find out the bookshelf, and there I am going to find out which row and which column my book is lying. So you can increase the number of dimensions as per your requirement. So now how many elements will be? Suppose if I have a 3-dimensional array of size 5 into 2 into 4. So the total number of elements will be 5 into 2 into 4, that is 40 elements. And it is represented in this way in the memory location. 0, 0, 0 represents the, what does it represent? The first element. Okay. 0th row, 0, 0. Okay, that way. And so on. So it is a 3-dimensional array. So that's all about our arrays. So in case you have missed any of the preceding lectures, you can directly go to the link and get more information about arrays. You can also post in the comments if you have any doubts regarding arrays or you want me to post something extra for you. Thank you. Please like, share and subscribe to CSE Core Concepts.